SpaceX engineers have manipulated another tech concept that violates rocket engineering. Perhaps they are trying to amaze us or tell the world how much they're damn good at developing a monster-like rocket that hasn't been invented in history, something called the super heavy flaps. Right now, making the super heavy flaps at the tail of the rocket glide like a wing is the latest outstanding achievement SpaceX engineers have invented for the whole world to behold. Stick around as we show you how SpaceX engineers dramatically transformed super heavy booster flaps at the rocket's tail to glide, a mechanism that swings up and down while it flies in space just as birds do. Let us first explain briefly how birds can fly in the sky, that is, the laws that govern flying in the air, before moving on to the main functions of the wings at the trailing edge of the rocket, and finally evaluate if it glides like a wing. When a bird is flying, its wings are flat, allowing air to flow readily around it in the direction the bird is traveling, like your hand cutting through the water or air. However, something unusual and strange occurs here. Since the wing is somewhat bent on the top, air flows quicker over the top than it does over the bottom, and because the air is traveling more slowly, there will be more air beneath the bird, and the air causes a push, and when they push against that large flat section of the wing, it lifts the bird. So, a bird wing cuts through the air in a forward direction and is pushed up from below, leading in a flying bird. Aerospace engineers applied this same principle to make the aircraft fly. Let me talk about that in a moment. When it comes to the commercial airplane, 4 forces are required for planes to fly. They are lift, weight, thrust, and drag. The airplane is propelled upward by lift. The movement of air around the wings provides a lift for the airplane to lift itself off the ground's surface. The pressure that pushes the airplane towards Earth is called weight. Airplanes are designed to distribute their weight evenly from front to back. This helps to keep the plane balanced. The force that propels the airplane forward is known as thrust. Airplanes get thrust from their engines. When walking against a strong wind, you may experience drag. Airplanes are built to let air travel around them with as little drag as possible. When all 4 forces are in equilibrium, an airplane can fly. Most planes, however, require one extra thing, and that's a pilot to fly them. Let's look at the takeoff principle of an airplane. Just as we all know, a rocket uses vertical takeoff and landing principles. To an airplane, everything is a different ballgame. In the case of an aircraft, the wing's lift properties are determined by its cross-sectional area. Pardon, these details have to go with many engineering terms, but if you're watching this video, you could have a thing for engineering. That'll make you love more of our videos, so hit the subscribe button. Let's stick together, buddy! Now back to our discussion. The wing creates enough upward thrust to lift the airplane off the ground at a specific velocity. The aircraft will remain in the air as long as its airspeed remains greater than its liftoff airspeed. The amount of lift is controlled by the pilot using both airspeed and the wing's angle of attack. The greater the angle of attack, the slower the airplane must fly. For many aircraft, the maximum angle of attack is roughly 17 degrees. The wing will stall and the aircraft will fall if the maximum angle of attack is exceeded. This is referred to as the stall speed. Because the air at the top of the wing is longer than the bottom, the top air must accelerate to reach the bottom air as it passes over the wing. This results in a drop in top pressure. The wing lifts compensate because of the increased pressure on the bottom and lesser pressure on the top. According to Bernoulli's principle, faster moving air has low air pressure while slower moving air has greater air pressure. Wings, propellers, and helicopter rotors all function in this manner. Bernoulli's concept is a single principle that explains how things heavier than air can fly. They all drop like a rock on Newton's apple when they are motionless, no airflow. Now, coming back to the newly designed wing attached to SpaceX Super Heavy booster. After a successful cryogenic-proof test, SpaceX's first orbital class Starship prototype was photographed expanding its wings. While this is a tiny step in comparison to practically any other testing milestone, it serves as a reminder that the ultimate aim of Ship 20's test campaign is a launch on Super Heavy to orbital heights and speeds. If the launch proceeds as planned, Starship will seek to survive an orbital class re-entry for the first time, pushing it to intense temperatures and putting its many thousands of heat shield tiles to the ultimate test. Dozens of things might, and probably will, go wrong, yet practically every system aboard must function flawlessly to guarantee that the Starship survives re-entry in one piece. Even if all goes as planned, the same systems will need to hold on for many more minutes to undertake a free fall, engine restart, flip, and landing maneuver that only 2 previous Starship prototypes have done. One of such critical systems happens to be the Starship's flaps. Starship's 4 huge flaps are only capable of rudimentary flapping motions thanks to actuators driven by Tesla Model 3 and Y models and a pair of Model S batteries. While they may appear to be wings, Starship flaps aren't intended to provide lift like in the case of an airplane. Instead, they function more like the hands and legs of a skydiver. You remember what skydivers wear? That's what we're talking about, especially one wearing a wingsuit, allowing them to regulate their pitch, altitude, and roll while free falling belly down to Earth. This same scenario allows Starship to get nearly all of the benefits of a structural wing like the one on a skydiver, while incurring a far reduced mass penalty. Instead of gracefully slowing down with its wings, Starship utilizes its flaps to generate as much drag during descent, falling to a terminal velocity of roughly 100 meters per second or less. Using a freefall trajectory with flaps incapable of creating lift will almost certainly lose cross-range performance, which means how far the Starship can move horizontally in Earth's atmosphere after re-entry. Starship's flaps are vital for managing vehicle orientation and direction during re-entry and letting it maneuver to a modest vertical landing platform or enormous Mechazilla catching tower. To play the job, the flaps must be able to activate over their entire range of motion during re-entry when Starship's supersonic attack on the thin upper atmosphere unleashes a rush of superheated plasma eager to locate the cracks in its heat shield. Shuttle engineers faced the same problem, eventually devising intricate seals to allow the vehicle's wing and body flaps to react during re-entry without letting superheated plasma seep inside and destroy their fragile systems or structure. Although Starship has the advantage of almost all of its structures being made of steel rather than aluminium, it still faces the same challenges in shielding sensitive electronics, actuators, motors, and other components from the re-entry onslaught that its heat shield and steel structure are designed to withstand. It's unclear how SpaceX hopes to seal off the more sensitive, exposed components of each flap's actuation mechanism, including motors, cabling, and the hinge itself, that are only half covered with heat shield tiles. Starship's flaps and the cradle-like aero surfaces slide appear to have very tight tolerances and may rely on felt-like ceramic wool or TPS blanket to seal the minuscule remaining gaps. So in a nutshell, the purpose of the wing on SpaceX Super Heavy is not to generate lift like in the case of an airplane, rather give it a balance during re-entry in the Earth's atmosphere. They appear to be fins or wings, but they function more like air brakes on the Starship to create drag, more precisely like the arms and legs of a skydiver for full control of altitude, translations, and fall rate. I've been calling them flaps, but whatever SpaceX and Elon Musk name them, we should call them. But Elon Musk himself referred to them as flaps in tweets after SN8, so let's keep with that. Flaps would help to eliminate any mistakes with Super Heavy's grid fins. To an extent, if you get confused about the flaps, it'll appear as they work similarly to aircraft control surfaces or wings that control and direct the primary lift of an aircraft's wings or the Starship body. What other use do you think the flaps will serve for the Super Heavy booster? Be sure to watch your favorite SpaceX videos here.